Today is Monday, April 7th, 2025, and this is Spring Office Hours, Season 4, Episode 9, Running MCP-Based Agents on AWS with James Ward. My name is Dan Vega, Spring Developer Advocate at Broadcom, joined by my good friend and colleague, Deshaun Carter. Deshaun, how's it going?
I still don't have cloud money. I only have Raspberry Pi money. Today, what we're talking about, running MCP on AWS, is it still going to be relevant to me? Am I still going to learn something if I don't have money to go to AWS just yet?
Of course.
Okay, fantastic.
Especially with our guest today, you're going to learn a lot.
I'm a big fan of our guest.
Yeah, me too. But before we get into that, this is Spring Office Hours. We are live here in a live stream. So if you have questions, get your questions in. We'll see if we can't get them answered today. If you missed the live stream, you can catch the replay on the Spring Developer YouTube channel or wherever you get your podcasts. It is April. I said at the beginning of this, I'm like, wow, we are into April already, Deshaun. Pretty crazy. What have you been up to?
Well, I got burned a few times on April 1st. I was traveling, I guess, and I was like, what is this? What is happening? And I forgot the date. But other than that, yeah, I've been traveling quite a bit, having a lot of fun. I really enjoy hanging out with our customers. But yeah, this MCP thing is taking off. So what I'm doing, I'm repaving everything again. All right, that's one of my favorite jobs, is like just refactoring the home lab. And I have all of these servers. I've got all of these different clusters and Cloud Foundry foundations that I want to run and I want to connect to, but I want to connect to it with natural language. I don't want to build a bunch of dashboards. So that's what I'm working on, is I'm doing a bunch of Spring AI, a bunch of text-to-speech and speech recognition work. And I'm trying to lean in. I'm trying to find my inner Dan Vega and lean into like these AI-driven workflows to just speed up things, right? To have more fun, speed up things, and not worry about the little things. Like let the AI things help me in learning new technologies. Maybe I don't want to go deep on text-to-speech. Maybe I just want to get an example up and running out the door. I was able to do that quickly, and it's fun. It's a great time to be a Spring developer.
Yeah, and if you missed it, we did a show on Model Context Protocol last week. I've been getting a lot of really good feedback on that. So if you have not had a chance to check that out, go back through the archives and listen to that one. I thought it was a pretty good show. Good overview of what MCP is and why you might want to reach for it. But we'll kind of continue that conversation today.
Dennis shared that he's from Botswana. I just wanted to say Botswana because that's a great word, great name, Botswana. Dennis, thank you for letting us know where you're from, because my parents are always watching the show and it's always fun for them to see where people are joining from. So if you're here, say hello and let us know where you're joining from. And also, reminder, when you come to my house for dinner, if you leave hungry, that's your fault. Today, you're going to have questions. If you don't ask your questions, that's your fault. So if you're here live, don't leave hungry. Ask your questions.
Agree. All right. I think we should bring our guest on and have a little fun with this conversation. So without further ado, I'm going to bring on James Ward, Principal Developer Advocate at AWS. James.
Hello. Welcome. Thanks for having me.
How's it going? How are you?
Good. It's a beautiful day in Crescent Butte, Colorado. The ski area just closed yesterday, so ski season is over. I did not get out to ski enough this year. Too much MCP was the problem there.
Well, that's okay. I mean, that's time well spent, if you ask me.
We'll make it for next year.
That's right. Exactly.
So, James, I've been following you for a long time, and we finally got to meet last month at DevNexus, which was really great. Awesome. Yeah. By the way, if you're ever starting a axe throwing league, Deshaun and James should be your number 1 and number 2 picks.
Darts throwing. Yeah, Deshaun got first place. I got second place. We were crushing the darts. It was super fun.
Yeah, you guys were great. But just for anybody who does not know who you are, can you give us a little bit of an introduction, who you are, what you do?
Oh, here's a question from the audience.
Yeah, ski or snowboard. I used to snowboard. I grew up snowboarding, and then when I moved up to Crescent Butte, our local ski area, it's not a super good mountain for snowboarding. There's a lot of like traverses and flats and stuff, and so I switched to skiing. And so for the last 10 years or so, I've been on skis and still have no idea what I'm doing. You know, I'm always like, how did that leg get behind me?
I know that move.
Whereas on a snowboard, it's a little more. Easy to keep your feet in the right place, I guess. So yeah, skier, backcountry, cross country, uphill, downhill, all the
fantastic.
Nice. Yeah, so great to have you. So a little background about me. Been at AWS a year, so still learning things there. Before that was at Google. Spent a couple years on the Kotlin team working on Kotlin stuff at Google. Before that was on Google Cloud, and then Salesforce, Heroku, Flex long ago. Someone pointed out. So yeah, and been a huge fan of Spring for a very long time. So back in the old days of Flex, which was mentioned, was doing Spring, and Jeremy Corelli had built this Spring Flex thing, and so I did some work around that. And yeah, I mean, what a breath of fresh air in those days from the J2E stuff that I was doing. So, yeah, so huge Spring fan, love it.
Good times. We've been in the software game for a long time.
Yeah, that's so funny that somebody brought up Flex, because I was really big into Flex back in the day. I was in the Adobe side of things, doing Cold Fusion stuff, doing Flex stuff. So that was a lot of fun.
It was fun. I still haven't found a UI framework that I like as much as Flex. Like, it's
it was great.
I could do Flex, and these days I'm like, I can't. I just can't even do it. UI is just too hard. But now I just have the AI do UIs for me.
The robots write our UIs now.
That's right. Exactly. Yeah. So I guess as a little bit of background for this, last week we did a blog post and a video that got a lot of help from Josh Long on. Josh and I recorded a video that went through kind of what I think looks like the future of how programmers like me will use AI in their larger systems. As some background, I always kind of shied away from diving deep into the world of AI because it seemed a little daunting. It seemed like kind of Python centric. And so I first started really diving into it back in December. And MCP was part of the reason for it. Was okay, MCP seems like maybe something that'll make this world of AI more relevant to my world as kind of a back-end software engineer. And so built some stuff in Python that seemed to be like the path of least resistance at the time back in December. And I was like, oh my God, I have to do so much like data structure munging. I've got my MCP servers, they're returning some data format. I've got to like munch that into the format to send over to the LLM. And it was just gross. I don't know. It was, I was like, I don't want to deal with all this like low level data structure munging stuff. And so then at DevNexus ran into Josh, and Josh was like, I got to show you this stuff. And so he showed me like what was literally like 1,000 lines of Python that I'd written. We did it in like 20 lines of Java in Spring. And I was just like, oh my God, this is amazing. So I was like, Josh, we got to record a video. We got to do a blog and did all that. So it's been super fun to be diving into the Spring side. It just makes it like so easy to bring these things together with the LLMs and your tools that you're using. So yeah, I'm hooked. It's been awesome.
Especially around LLMs. Go ahead, Dan.
Yeah, and I think like one of the things that we've been kind of doing, whether it's talking to developers, talking to customers, over the last year, 2 years, is really been like, hey, pick your favorite programming language. If Python's your favorite programming language, that's great. But AI is not synonymous with Python anymore. It was for kind of building these large language models and training them, but every language is a consumer of these large language models now. And so we could take advantage of them. And obviously now we have some really great tools in our space as Java developers to take advantage of them. So
exactly. Yeah. And what I see happening is that for I think the I don't know, initial periods of LLMs, it wasn't super relevant to me as a backend engineer, but the tools, the abstractions have all gotten to the place where now I think like any backend engineer can integrate AI into their systems. It's no longer this like you have to use Python or you have to like learn all the data structures and how the LLMs actually work and all the RAG stuff. Like it was pretty daunting to me. And now I'm just like, oh my God, I get this nice abstraction through Spring. Now it's something that is approachable to me and something that I could see actually building into the software that I build. So yeah, exactly. And so I think like bigger picture this year, many of the kind of typical backend engineers are going to be building agents, the like things that use LLMs, use MCP servers. And now it's not this like separation of roles where you've got the like people who really understand the AI stuff, and then you've got the backend engineers. I think those two this year are like really coming together, and a lot of our typical kind of backend engineers are going to be able to build agents and put them into their systems, just like what happened with databases is like,
Yes.
yeah, we've still got like database engineers who like really are experts on like how to like deal with the really detailed parts of like managing and running a database, but like most developers know SQL and can like build a database thing in their application. And I think that's where we're at with these tools with agents and LLMs, is now just like we use a database for stuff, we're going to use LLMs and build agents into our systems.
That is the metaphor that I've been using. That is, I say it's, these LLMs are like pre-populated databases, right? We've had Spring Data, which allowed me to, bounce back and forth between, Oracle or Redis or whatever. And now with Spring AI, I get that same kind of abstraction, and I can, hop between the different LLMs. And what I'm seeing, especially over this last month and a half of travel, is companies, there's kind of like three buckets. There's companies that are still like, we'll let you have Copilot and have fun. And then there's companies that have like, hey, we've adopted some LLMs. And then there's companies that are kind of doing the mature, and they're now going past the one LLM that's been approved to, hey, we've got multiple on the table, and we see how these different LLMs provide different strengths and weaknesses for these different workloads. And they've kind of, those are kind of the three buckets that I see.
And I've seen another bucket today. I don't know if you've seen what's going around with Shopify. They put out like a newsletter to their employees about AI use within the company, and they're like mandating, like, this is not just a nice to have thing. You don't have to use it, but you're going to be left behind if you're not using it. And so
that's on
there's kind of another bucket of like, hey, like, let's jump on in. The time is now, so get going.
Yeah, and there is like this progressiveness that you can bring to this, is like, you can just write a simple chat client, and with Spring AI, that's super easy to just like have like, add some chat functionality in your application. But then there's like many other like layers to it, just like with databases. It's like you can do just like basic CRUD stuff, but then you can do all these other things as well. And so with LLMs, it's like, oh, maybe we want to put like guardrails around this LLM, so it's not going to like, we protect it's not going to reveal sensitive information or whatever. And so that's yet another layer. You can do the vectorization of data, and so there's just like all these like kind of ways that you can expand on the basic LLM use. But just getting started with the basic LLM stuff in Spring AI is super easy. So.
And I think, for us kind of back-end developers, this is MCP introduces like a really nice protocol, because we're used to building integration layers, right? Like we're building REST APIs or GraphQL APIs that connect systems together. And that's really what MCP is doing. It's connecting some kind of system to the large language model where it kind of falls short, right?
Yeah. And maybe you went into this last week, but one thing I think that's important about MCP is that it initially and has been really focused on the code assistant extension, like being able to basically write plugins for code assistants. And that's great to have a way to do that. But I think that ultimately in the big picture of MCP and AI and integrations, that's like a very small portion of what MCP will be used for. Is like, we started there, we're developers, like we're going to build stuff for ourselves first in a way. And there's lots of great stuff around MCP for that space. But the much bigger kind of space for this is in the backend systems where we're doing all these integrations, and we need to have a way to plug in all these different data sources and different APIs into our LLM essentially. And that's where MCP for me is super interesting. And that's what my blog goes into, is like not the code assistant side. Sure, there's lots of fun stuff happening there, but really on the like enterprise system integration, weaving all these different things into the LLM and giving it access to tools essentially.
Yeah, I would say one place I think I wanted to start, at least on the AWS side, and I told James this before we got on today, I'm here to learn some things today, so I'm going to ask some questions. So, there are a lot of different companies out there that have large language models. Everybody probably knows of, things like OpenAI's GPT and Anthropic's Claude. But AWS has a large language model called Nova. And I have not heard of this yet. I have not had a chance to use it. Can you tell me anything about it?
Yeah. So let's unpack that a little bit. So on AWS, there's a service called Bedrock, and Bedrock is the way to do model inference. Inference is the sending a prompt and getting the LLM to give you something back. And so in Bedrock, you can use a ton of different models. I don't know how many models are available, but you can use different models. And so you can use the Anthropic Claude models. You can use other third-party models, but then Amazon also provides its own models, and so those models are called Nova. And so for the content that Josh and I did, we could have used the Sonnet Claude model, we could have used other third-party models, but we used the Nova model. Totally optional, like up to you, like which model you want to use. The key thing when we get into the MCP and integration space is that the model needs to support tools, and any model that supports tools can do the MCP integration that we talked about. And so I don't know a whole lot about models. That's not where my expertise lies. It's just like we used Nova just because I don't know, because it supported tool calls, and so we could plug the MCP stuff into it. So there are different Nova models that you can use. There's like Nova Pro and Nova Lite, and I think the samples that I used Nova Lite. Cool. And then we also Josh and I used another model for the embeddings, and this is where things get a little fuzzy on my knowledge of things. But in Josh's dog adoption service sample, there's a way to have the LLM have knowledge of a database of dogs that are up for adoption. And so we take that database and we vectorize it and then hook it to the LLM so that it can then like have knowledge of that data in the right vectorized form, which makes it more efficient, like find stuff or something, like
lots of math,
like plain text. Exactly. So we did use another model for the embeddings, which was called the Cohere model. And this is where my knowledge of embeddings and RAG and all that kind of stuff gets a little fuzzy. But so those were the two models that we used on Bedrock in our case. But yeah, any of the models that are on Bedrock you could use.
And that Bedrock is really nice because from Spring AI we have support for Amazon Bedrock. So now you can just give access to the developers to talk to Bedrock, and then you can kind of control what models they have access to, so they don't just willy-nilly use whatever model. And like, I don't know, like some of the models out there are very expensive. Maybe you don't want developers using those really, really expensive models, right?
Right. Yeah, I'm sure that there's cost trade-offs. There's maybe latency trade-offs. There's maybe models that are better at reasoning than others. And so I think a lot of different decisions go into, just like with databases, it's like, do I want NoSQL? Do I want relational? Do I want, key value? Like so many different ways to deal with data. And same thing is true in the model space. So and then maybe some that are better oriented towards like, okay, when I'm doing local development, I'm going to use Nova Lite, and then when I go to production, maybe I switch over to Nova Pro, or however you want to do that. But yeah, lots of different models available there in Bedrock.
Josh's demo where he vectorizes the data that already exists in a database, that he doesn't dig into it. He doesn't make like, hey guys, look at what I just did. But he does it so fast that the thing that blows my mind is all of this data that you have, that our community has, the enterprises have. They have all this data. They can literally vectorize it and then make it available to these LLMs. In Josh's demo, it takes like 32 seconds to do it. And then he says, hey, don't do it again because it's already vectorized, and then it's there.
Yeah.
That's mind blowing. And we don't double click. I try to double click on that every time I get a chance. But the other thing that you said was about these different trade-offs, right? If your data exists in AWS, the latency between your LLM that you're trying to use and that data, you might want to have those close to each other. That might make a difference if you want to have a good customer experience. And just those two things kind of connect the dots for me.
And we'd use PG Vector in that case to store the actual vectorized embeddings. And so that we could certainly run that PG Vector, on AWS, have that right next to Bedrock. In our case, we were just doing things locally, but with Bedrock remotely. But yeah, in production, you're going to want those things as close together as possible. One of the things that I think is still an open debate is around the architecture of RAG and vectorization, because you could do the vectorization and the embeddings like Josh and I showed, but you could also just call an MCP server and get that data from the MCP server. And I don't know if anybody's really come out with like a good approach on deciding like when should I do embeddings versus just an MCP server.
Versus like full blown, I'm just going to send everything, because some of these models have very large context windows now. So those lines are getting blurred. I don't think anybody really has a good answer of what to do yet. Like,
we're just getting started.
Probably on a case by case basis, right?
Yeah, exactly.
But today, I reach for RAG much less, because I have these tools where I can get the high fidelity answers instead of a vectorized similar, embedding.
Because the vectorization is a duplicate of the data that's creating another representation of it. Whereas when you call an MCP server, your MCP server is going to give the data structure that you want to give back. And so it's kind of maybe more adaptable to the use case that you have. Is like, yeah, I want this MCP server to require some user ID, or, be able to get the user identity when it gets called. And so then I can do a lookup just based on the user identity, and then only return the data in the right form that I want to back to the LLM. So there is, I think, maybe a little more flexibility with the MCP approach.
Well, we have a question here that kind of goes along that lines. Is it secure to use MCP agents on AWS production and give read access to agents? We have stored multiple secrets in AWS.
Yeah, so that's part of what the blog goes into, is like, okay, I want to run this MCP server on AWS. And so today, the way that we do that is we need to run it somewhere that can use server-side events as the transport. Yep. And so MCP today has two kind of real transports. There's the standard IO transport, which is mostly just used for code assistance and running locally. Like, you're probably not going to do that in your production cloud environment. So then in the production cloud environments, today we're talking about server-side events. There's a new version of the transport that adds something that will, I think, be more friendly to serverless Lambda, that sort of thing, called streamable HTTP. But those implementations haven't really landed yet. And so for server-side events, we in the blog post I went into running on ECS, which is just a way to run containers. EKS would be Kubernetes, whatever would be another option. But then that network transport is supported with server-side events. So you're going to call, and you can run this all in a VPC. So that's the example that I used, was running the MCP server in the VPC. So then I'm running my agent on ECS. So the agent is maybe we should talk a little bit about architecture. So the agent is this thing that like orchestrates the connection with the LLM, and then the connection with the things that it's integrating with, ideally MCP servers. So I'm going to run that agent, which is my LLM client and my client for my MCP servers, in a container, and then it's going to make the network call over to the MCP servers that it's integrating with, which are also, in the case of my blog post, running in ECS. And so that's the kind of network architecture. All that happens in my case in a VPC. So you've got the network isolation there, so that no one can just randomly talk to your MCP server. And then for the parameters of your MCP server, this thing is just HTTP. So one, you can secure it however you want to secure MCP. If you want to use secure transport, use HTTPS. If you want to require some kind of identity token, bearer token kind of thing, then great, require that token when that connection happens. And then you can establish identity, establish whatever you want to do around security of the person who's actually making the call. Maybe you propagate that all the way through where a REST call comes in, then we establish identity, then we pass the token on to the MCP server. So all that is certainly possible because this is built on HTTP as being the base protocol for it. So hopefully that kind of answers that question.
Yeah, and it's funny, we got a question last week when we were talking about MCP, and somebody asked, like, hey, does this integrate with OAuth well? And our friend Daniel Garnier from the Spring team immediately put out a blog post after that, securing Spring AI MCP servers with OAuth 2. So
awesome.
Definitely, I'm glad we got that question. I didn't know the answer to it at that time. But yeah, when you start building these things that are going to go off your machine and into production, these are the right questions that you should be asking, because we want to make sure they are secure.
Yeah, absolutely. Yeah, and so one of the things that I'm exploring right now is how do I take the little code sample that I built for what we did last week, and then do Spring Security in it and be able to do that identity propagation through all the calls, and so want to then bring the security piece to a follow up to that.
Yeah, I'll pose this to you guys, to anyone out there in the live stream. I think what I'm on this kind of like roadmap of trying to use MCP, and as you said, it's been kind of like, okay, let me start small and like build something locally. So I've built like a lot of these like local tools that, like, hey, I'm using Claude Desktop as the client, and I'm building these MCP servers to like integrate with other services so that I have access to them in an LM. I need to start thinking about like, building these things for servers, right? So like, I don't know, either of you, do you have like things that you're building for servers, or like what things could we start thinking about where we're building these not just for our local machine, but for production, or and integrating with other systems?
Yeah, I think there's so many different places that this will go, because what the LLMs have no knowledge of your data, right? They have no knowledge of even things that are kind of right now. So like the weather right now. And so anything that goes beyond what's in the model, the knowledge of the model that you need to extend it with, that's a great target for building an MCP server and exposing that data to your agent, essentially. And so that then you're augmenting your LLM with this data, which could be and it doesn't have to be read only. I think that was part of that question too, is so you can have MCP servers, all they're doing is like RAG style, like fetching data, but the agent is one of the things that an agent is generally supposed to be able to do is do things on your behalf, which means taking actions. And so then these things should also be able to hook to your existing REST services. And so in the case of like Josh and I's example, we were scheduling an appointment. Well, scheduling an appointment requires some like ability for the LLM now to be able to actually do that schedule call and say, okay, I'm booking this time with this person for this service, and that would then require some external place where you actually are keeping track of scheduling. But that is a great example of an agent being able to like act on your behalf to actually perform some action. And so of course you could expose that as an MCP server and have the LLM then be able to actually take that action on your behalf. So not just about kind of the read-only data side.
Yep. A lot of what I've seen over the last few weeks is the places that these are going. I don't know which team. I think it came from the Kubernetes, one of the SIGs, where they've added an MCP server that implements or gives access to the Kubernetes API. So I can say like, hey, what are my namespaces? What namespace is this pod in? And I can use an LLM to go and figure that information out. Switching context, like I want to talk to my production cluster. I want to talk to my non-production cluster. These types of things are mind-blowing. And of course, Cloud Foundry, but where we're seeing these things go is where my head goes is like the interface that I'm seeing has changed, like making all the fancy UIs for all these things. That is like, it's not even a question anymore. I want a chat interface with an LLM so I can use my voice. I can say, hey, where is this pod running? How many instances of this pod do I have running? That's where everything is moving. Yeah. This natural language interface.
So there is the natural language interface side, which there's endless possibilities for how we use that. But one of the other ways I look at this is like, one of the challenges in the enterprise is like, I've got systems and those systems need to talk, and the data structures need to match in some way. And so there's many different ways to accomplish this with we've got protos, we've got all sorts of different kind of ways to model the data in a way that we can do integrations, OpenAI based stuff, whatever. But there's a potential also to essentially do like the MuleSoft style, like enterprise integration of bringing systems together, where maybe the bringing together is actually fuzzy and not something that's like hard coded through like a specific proto, where you could actually like, maybe this only works in some use cases and you want to have some guardrails around how you do it, but you could actually tie two systems together in an integration in a fuzzy way where the LLM figures out how to map the things in one to the other. And it'll be interesting to see like how this all percolates into the enterprise integration space as well.
I'm just thinking about like so many times that I was asked by leadership to like create some dashboard or some system that gave them insights into like customers and different platforms. And now we can just write these agents that have access to that data, and they can ask whatever questions they want. I don't need to write these specific dashboards based on the requirements. They can just like free for all ask questions about all of this data that we give them access to. So
And a big part of that is like essentially workflow, is where you would have to figure out statically at development time, okay, I need to talk to this database and get this piece of data. I need to talk to this REST service and get this piece of data. And then I need to munge those data structures together. And what we have with the LLM is essentially a dynamic workflow that gets determined by a prompt, and the prompt and the tools then figure out, okay, it's going to figure out the workflow. Okay, I need to get this data from here, and I need to get this data from here. And so it's like this dynamic workflow system that has some trade-offs to it. Like that's no longer as deterministic as what you would build statically, but then it allows you to build something that would be a dashboard that you didn't have to pre-program all of the ways, all of the paths and integrations that would be needed to get to what the end user actually wants, because it's dynamic, and the LLM is going to figure out what needs to happen to get to the result that the user is asking for.
For years, the whole like, how do I search my data? You know, we had, this is just, old. I'm old. All these different ways. Oh, I want to find out how to do this. And we had these different like mini languages, like around Lucene, like, hey, you can query things using Lucene's language. But now that whole paradigm, the whole like ability for me to search across data is which product sold the most in the last 24 hours.
Right.
But then I can say, what state in the US sold the most, or where was it being bought from? What time of day? I don't have to go and pre-generate a bunch of dashboards. I can literally ask the data, and I get this natural language like, oh, this is.
And how did this relate to the weather on that week, you know, or whatever? Like who cares what data sources like people are going to munge together? Like they're going to.
I've seen a lot of like natural languages to SQL too. Like, hey, instead of having a developer write the endpoint to get the data that you're specifically looking for, give me the first name and the last name of customers in the last 10 days. And that translates to SQL. And now you just get that data back. So a lot more flexible that way, which is really cool.
Yeah.
Two of the terms you put in the article that we've heard of a lot lately, we've kind of heard that 2025 is the year of agents, right? And so I want to get your thought on like the definition of like an agent versus like an agentic workflow, because I think they're two different things, right?
Yeah. Good. And I may get this wrong, because I
don't think so, because I don't think there's a standard definition of anything.
We can make up a new one.
That's right. Yeah,
we can make up a new one.
We're in the phase of all this where the terminology all blends and no one's really sure what anything means.
Yeah.
So I guess here's the way that I would put this. An agent is something that you can assign a task to, and the LLM is going to then figure out how to get to the result of that task.
Yep.
That's an agent.
Yeah.
Agentic is, for me, specifically a while loop around an agent. And so this allows the experience of using that agent to go on across multiple conversations, like multiple messages that you're sending to it, across multiple interactions with external systems, other things that could be coming into it, other signals. And so it's the while loop that is around the agent that makes it agentic. And I think a lot of developers have already experienced this with their coding assistants. Coding assistants are, at least the agent ones, are agentic. They've got this while loop. They're going to just keep running until they reach the goal that was asked of them, or the user stops it. And so I think the coding agents are essentially agentic because they've got that while loop.
Yeah, so I think for the most part, the things that I've been building, at least like tools and locally, are really just workflows. I may build like a couple different agents and then just kind of stitch those together. Like, here are the different tools you have. Go use those and complete the task that I kind of gave you, right?
Yeah, exactly. Yeah, was that helpful on agent versus agentic?
Absolutely. Yeah, for sure.
Yeah, it works for me.
And the AI people may totally disagree with my
James out here ruining our definition.
Because in some ways, an agent itself is also kind of a while loop that the LLM is driving. Because in a conversation with an LLM, it can actually like kind of internally do a while loop. And so the way that works under the covers is I send a message, the LLM responds, and it may respond with, okay, now I need you to call these tools, and then it's up to the client, the thing that is running the call to the LLM, to then actually do those tool calls to MCP servers, and then feed the responses back to the LLM. But then the LLM may say, based on what it got back, it may say, oh, now I need you to call more tools. And so essentially it is still a while loop. It's just a while loop that is kind of in the context of the LLM call. And then usually in this case, you're waiting until the LLM has decided that it has achieved the goal, and it'll say, I'm done now.
Right.
And then your request to the LLM is then completed.
Right. One way I've been kind of thinking about it, and again, I don't know, we're all just guessing at this point, but there's kind of deterministic and non-deterministic, right? Like if I give it a workflow, I know it's going to perform like these 5 steps. I don't quite know what the answer is, but it is kind of deterministic what I'm going to get out of it. In another scenario, non-deterministic is I'm giving you a task. I have no idea what you're going to end up with, but hopefully it's going to be the right thing.
Yeah.
So.
Yeah, I mean, I think there is some fuzziness to the workflow where it may at different times decide to take different paths in that workflow, and depending on, because the LLM, if you ask it the same question multiple times, it may not always give you the right response. And I guess you can control that with the temperature knob, right? Temperature knob tells you kind of how much randomness to
how creative to get.
And so maybe if you turn the temperature down or up, I don't know which way it is, then you could make that more deterministic if you want. But yeah, I think the default usually is that there's some fuzziness in there, and the LLM may decide to take different paths through the workflow, but always it's trying to achieve the goal. It may just come up with different ways to do that depending on the temperature.
Cool. So I know we talked a lot about architecture, but if I want to get started on AWS, I want to build like a simple agent. Can we just kind of talk through that again? Like, what are the services I'm using? How would I like build this out? Because like I have an idea for one, I'm not quite sure how to implement it yet.
Yeah, great question. My blog post goes into all the details of that. So read through that, but I'll walk through it. So first thing that we need is, let's start with our MCP server. We're going to have some way for this agent to be able to get to some external data, external services, those sorts of things. And so we define our MCP server, and then that is going to run over HTTP. So we need to actually stand that up on a server. And so in my case, I use containers. And so you could do Kubernetes or ECS. So you're going to run that server. Then you get the endpoint to that server. Then we're going to use that endpoint, but I'll pause there to see if there was questions.
No, so before I even like publish to production, then I'm just writing. In our case, we're using Spring AI to create an MCP server. I developed that all locally. I can test that all locally. At the end of the day, I'm just taking a container and I'm pushing that to AWS.
That's right. Yep. Cool. Yeah. Exactly. And it's just a standard HTTP server. I used Spring Web, so Tomcat-based server, and yeah, all ran locally. And you could test that in a variety of ways locally. There's a tool that I use for testing called the MCP Inspector, and I think
I was going to ask about that. I saw that tool. I'm not familiar with that one. What does that do?
So you spin up your MCP server, and it's got an endpoint. If you're doing HTTP transport, you can also use standard IO. It doesn't if you're running on the same machine. But you spin up your server, and of course, Spring AI supports both standard IO and server send events. So however you want to do it. But for our cases in network land, enterprise land, we're talking server send events, HTTP. So we spin up our server. Then I start up the MCP inspector. The MCP inspector is itself a web server. It's going to proxy and connect to my MCP server, and then it allows me to explore everything that's exposed on the MCP server. So the MCP server exposes like, here's the tools that you can call. And so the inspector, you can make the list tools call through the web UI. It says, okay, here's all your tools. And you click on a tool and it's like, okay, here's the input parameters to that tool. And then it gives you a little web UI. You can put in your input parameters and say call tool, and then it does the tool call for you.
That's really great. And I just want to stop you there because I was building some local things using Claude Desktop as the client. And so my workflow was I had to constantly like close Claude Desktop, open it up, and then like I'd see an error and I have to go back, adjust code and relaunch that, see an error, and like look through the logs and find out what's going on. So it sounds like before I even get to using it in a client, this MCP inspector is going to like really help out that kind of development workflow.
Yep. And in your case, even with Cloud Desktop, you could probably set it up to work like what you wanted, where you're going to, in your MCP config, you're going to say execute the boot run task, and then you're going to have Spring DevTools installed. And so what I don't know is so when Spring DevTools restarts that server, is Cloud Desktop going to notice the disconnect and then
No, I haven't found that. I've had to like relaunch the client every time.
That's too bad. So
again, we're 4 months into this. So.
Will, exactly, it's all brand new. But hopefully the code assistants will get to the place where they could automatically establish a reconnection.
Yeah, and I could be wrong, but I think that's what the next kind of protocol will be with the server send event stuff. Like, and instead of having to constantly ask, "Is this thing okay?" It like will send things down to you. So.
And only a few of the code assistants today support the network transport for MCP, but I'm sure that that's going to change quickly. So maybe in the case of like local development, like you were doing, if you're using a code assistant that can connect over SSE, you could still do your boot run to start up your server, and then hopefully the client will be able to then notice the connection drop and reconnect, and so you could get the flow state vibe coding, thing going on with as you're building your MCP server.
Nice. Now so we're taking a container, we're pushing this to AWS, and you mentioned earlier until this other kind of protocol is like flushed out, this is going to run on something like ECS, not on a Lambda yet because that other thing isn't there yet.
Yeah, so the initial protocol was a stateful protocol, the server send events one, and it's kind of tricky because, and I need to do some more research to see why they did it this way. But essentially what you do in the MCP, the initial network protocol was you open a connection to a server send event channel. And now this becomes the ability for the MCP server to, whenever it wants, send a message down to the client. And there's a variety of different messages that the server may want to push down to the client. So for instance, there's the ability for MCP to change its list of tools dynamically. And so when you change your list of tools, tool setup happens like at startup, basically.
Right.
And so you get
here are all the tools that I can perform on your behalf.
But over a long period of time, maybe your list of tools on the server is changing. And so there's an ability in MCP for the server to notify the client that the tools have changed. And so that you need that notification channel. So you've got the server send events channel that is for the server to send messages back, but then the client needs to be able to invoke tools, get the list of tools, and then there's other parts of MCP as well, but it needs to be able to send these messages. So what happens is, I think it's on your first connection to the server send events channel, it tells you a URL that you send post messages to, the right channel for MCP. And so now you've got two endpoints, one that's like stuck open with server send events, you've got your right channel. And so then whenever you make a call from then on to the server, you're going to send a post event to this other endpoint. So now you've got two different endpoints that have state shared across them, because you have to know, actually, when you do an invoke tool call, that comes with an ID. And when you get the message back on the server send events channel, you need to correlate those IDs between the post on one and the event that comes out the server send events side. And so you've got state across, you've got the long lived state with the server send events channel. So overall, this is not very serverless friendly, because is a stateful service that's nailed open with server send events. And so just last week, I think it was March 26th, 2 weeks ago, there was an update to the MCP specification to support what they're calling streamable HTTP, which looks like it'll be more friendly to serverless environments, because it doesn't require the server send events and the right channel and the state across those and all that kind of stuff. But you can also still upgrade to server sent events. So the server sent events channel doesn't go away. It
Yeah.
becomes an optional protocol that if the client says I can do SSE and the server says I can do SSE, then they can upgrade to the SSE channel.
I heard it was described as like the best of both worlds. You kind of get both, so that's really good. And to me, like an MCP server really lends to like being a serverless function, right? Because this is, unless you're like in an organization that is just hammering this MCP server, this is usually something that is not long lived. Like it's going to take a request, it's going to return a response, and it can go away and shut down. And as Deshaun said, not all of us have cloud money. So if I can put it on a Lambda and only pay for it when I'm using it, this makes a little bit more sense. So
yeah, absolutely. And I think, as you said, there's a lot of use cases that are basically just request response. And so in those cases, serverless is a great option there.
How do we scale?
Yeah, I mean, Spring Web Flux is great. I was running my MCP server. Did I say Spring Web? So I actually ran my SSE server on Web Flux, and so I think I ran the client maybe on Spring Web, but my server sent events MCP server was using Web Flux. So that is, reactive is great for this. You don't want to like have thread per connection for server sent events, because then you're thread bound, and maybe there's some things that that we could do with the virtual threads. Thank you. Around this as well, but in my case, Web Flux, great. Now we're not thread per connection. We can keep those server sent events connections open without having to allocate a thread for every single one. That all works today, obviously, with Web Flux, and so that's supported. So I would say, for high traffic, don't be thread per connection on server sent events. That's not going to scale well.
Yeah, and if you go to like start.spring.io and pick MCP server as like a dependency, Reactor is kind of baked into that. So and we mentioned this last week, but one of the cool things is the MCP server that you're using. If you go to like start.spring.io, this was donated to the Anthropic. So they kind of adopted this as the official SDK for Java. And so, yes, you can use this with Spring, but you also use this without Spring. So if you're a Java developer and you don't need any of the Spring framework stuff, then you can kind of use the dependency that's listed in the documentation. So go ahead and check that out.
Yeah, and it's great that we have kind of one standard library now for Java MCP stuff, and then we've already seen Quarkus building on top of that. I'm sure many others will as well, and so it's great to see that happening where it's let's all share the same foundation of MCP stuff. Super kudos to the Spring folks for driving that initial effort.
Yeah, that's pretty awesome.
There's a couple questions here. One is a kind of a comment like, hey, yeah, we can scale, but there's always a cost for LLMs. And I'm going to jump back over here. Like, what's the feasibility of running this local LLM with MCP and putting all the guardrails so I can just say, I only want to expose this stuff? I think we've covered it, but yeah, you don't have to do this in AWS. At the beginning of the show, I said, hey, I want to do this local on my Raspberry Pis. So it is entirely feasible because we have LLMs that we can get off the shelf, that we can use freely on something like Ollama, and maybe now even on Docker, right? Docker has this ability to run models. And then we have Spring AI, which gives us this nice abstraction to leverage MCP with those LLMs.
And so all you need is an LLM that supports tool calling. And if you have that, you should be good. And so Ollama models, there are a bunch that you can run locally, like small parameter models that run on your machine. And as long as it supports tool calling, great, you should be fine. So totally up to you, like how you want to run your LLM.
And you can give these all a spin on your local machine before you push them to AWS using that kind of workflow. So
I don't know what Party Rock is.
Like this.
Oh, that's a good question. Party Rock is like this fun way to play with LLM stuff on AWS, and so I'll have to explore that because maybe that would be a fun integration with Party Rock and MCP.
Okay.
Yeah. Vikram,
good question. Thanks,
I'll explore that. I don't have an answer to that one yet. Okay, so let's continue with the architecture.
Yeah.
Real quick. So we talked about the MCP server side, but then there's the client side. So the client side is the thing that's actually talking to your LLM, whatever it may be on Bedrock or Ollama, whatever you want.
So MCP servers, you could have a bunch of them, and then you have one client that kind of uses all of these different servers.
Yep, and that's where your agent is. Your agent is the thing that's going to talk to the LLMs. It's going to make an invoke model request essentially to the model and say, here's a bunch of stuff. Now give me your response.
And the client is what takes in the request. So I send an HTTP request to the client, and then that fans out and talks to all the different agents.
That's right. If you choose to expose your agent through a REST API, which I think that would be pretty typical, but not the only way that you can run an agent in many ways. Like our code assistants are an agent running as a local command, using standard IO. But yeah, it's in the enterprise use case. I think a lot of these agents will be exposed as REST endpoints. So yeah. So request comes into in that architecture. Request comes in through REST. You make your API call to the model. So you say invoke model. The response comes back to the agent. And this gets all handled for you in Spring AI. But then what happens is if the response from the LLM said, I need to call tools, then your agent is actually going to call your MCP servers. So in that case, your agent is also a MCP client. And your MCP client is how you connect to the MCP servers. So when you create your MCP client, you give it the endpoints of your one or more MCP servers. And then when the tools get advertised to the LLM, it's using what you defined in your MCP client. But then when the LLM says, okay, now call this tool, you then know, or Spring AI does this all for you, so you don't have to do all this stuff manually, which is super nice. But it will then do the call to the MCP server, get the data back, and put that back into a call back to the LLM, do another call back to the LLM, which is giving that data or whatever it needs back to the LLM, and then that process can continue until the agent, the LLM, has decided that I'm done with that task that you gave me.
Cool. And then I think one of the things I saw in your article is there's a little bit of orchestration here. There's a few different components. So I think you use like cloud formation templates in there as well. So that can kind of put all this together for us.
However you want to actually get the stuff running. I did use cloud formation in my case, but you could use Terraform. You could just, go into the console and say like here's my container, run it. So totally up to you how you want to actually get the stuff running in production.
Cool.
I'm a big fan of IAC. Part of the reason is that I tend to forget things that I've spun up in the cloud, and with IAC, it gives me a really easy way to be like, okay, here's this thing and all the resources that got allocated underneath, and when I'm done with it, hit delete in one place, and boom, then I know all the resources that I had spun up. So I tend not to use console to actually create things. I tend to like it creates makes things more challenging, but I tend to always do even for simple stuff tend to use IAC.
The console is a great way to get started, but no matter what cloud service, I log into it a month later and I'm like, oh my gosh, this thing's still running.
I don't want that.
I mean, luckily
that.
The first rule of anything cloud is make sure you have your billing guardrails on, don't spend more than this a month, because you don't want to wake up to one of those bills.
Yeah.
And now that's the thing, right? That's the funny joke. It used to be, I left a Hadoop cluster on over the weekend. Oops. And now it's, I left an agent running against Bedrock over the weekend. Oh no, what happened? I mean, the amount, the size of the bill that we're running up is very different. But still, hey, I hit 20 million tokens over the weekend, which still, that bill is still tiny.
It depends on your model.
Yeah.
Well, now the running joke with MCP is I keep seeing this cartoon go around. It says, sell me this pen. And the guy goes, this pen has an MCP server.
There you go.
All about MCP. It's the hotness right now. But I think there is a lot of hype around MCP, and the code assistant side, as I was saying earlier, there's interesting things there, and there's thousands of MCP servers now that are for code assistants. But I think what we're going to see in our space is for the whole other side of things, which is more on the enterprise integration, our backend systems, all that kind of stuff.
If you are using code assistant, so it's a great way to get into discovering MCP servers, because code, these windsurfs and cursors have the ability to do all these things. But there's some MCP servers coming out that are really nice. Vaadin is creating one to give you updated documentation, which
I was just going to mention,
anybody
we just released one for AWS, which is takes the AWS documentation, exposes it as an MCP server. The great thing about that is that if there's a new document added right now, then my MCP server has access to it.
That's
right. So if you're using like Windsurf or Cursor, now I'm making sure that whatever I'm asking it to do, it has the most relevant information, and I'm not asking it to write code that it knows about from like a year or a year and a half ago, right?
Because who wants to use that? It's a year and a half old. Nobody's using that code.
No. And you as the developer get to decide which MCP servers you want to plug in.
Yeah.
And so this is an extensibility model to the code assistants that is super needed, because of course I want to be able to, like, I want an MCP server for me. I want to take me and turn myself into an MCP server so that it'll actually, when it gives me code back, I want it to write code in the way that I write code. My code. Yeah. Don't write this like the rest of the internet does, because I'm weird and I write code in a weird way. Write it like I write it.
Right. I got another question here. The MCP client in start.spring.io would be used to implement my client. Is this also agnostic to a framework? Can I use it independent of Spring? For this case, no. Like if you go to start.spring.io and ask for an MCP server or an MCP client, that is specific to Spring. But if you want to stand up an MCP server in just Java, head over to mcpprotocol.io. There are documentation in there to say, like, this is the dependency that I want to bring in. I'm not bringing in Spring. And you can get started with MCP and just Java there. But when you go to start.spring.io, you're bringing in the Spring bits with that as well. So
yeah, and then you're also going to, in the case of your MCP client, you're going to bring in a way to talk to the LLM. So in what Josh and I built, we used Bedrock to be the Spring AI Bedrock integration to be the way that we talk to the LLM.
Cool. Well, we keep saying like the MCP train is rolling. There's a lot of hype around it, but I think this is something that is really going to stick because everybody seems to be adopting it. Again, this came out of Anthropic, but this is not just for the Anthropic models. Obviously, everybody's using it. OpenAI came out like last week or 2 weeks ago, said they're adopting it. Google hinted at their adoption of it as well. So this is, I'd say this is no longer on the assess radar for me. This is definitely in the let's start to adopt this. Yeah.
Would agree with that. It's
going to be fun. It's going to be a fun year seeing what MCP servers pop up. Like you said, we've seen them a lot for local tools, which is a great starting point, a great use case. Like play around with them locally, see what you can do with them. But I think we're going to see these more in the enterprise and more in the integration space, which again, Java and Spring are both perfect for us. So
Yep. Fun times.
Look at that. An hour.
God, it just flies by.
It would just fly by.
It flies by.
Yeah. Well, it's super fun, and I'm excited to see what people will build with agents, because I feel like we're really entering this new era around software development. Things are going to change. Agents are going to be just integrated into everything, and so so it's going to be.
What's the coolest thing that you've seen, James?
For agents?
Yep.
That's a good question. There is some pretty wild stuff that people are building into their enterprise systems. I don't know if I can talk too much about it, but it's imagine an AI with access to all of your internal enterprise systems and data, just the things that it could do. Like it's totally wild what this is going to do for I think your dashboard use case is a good one, because it's like creating these like static workflows, static ways to like assemble data together is hard, and it made us move slow, and now we can move so much faster when we can just do things dynamically with an LLM determining how to munge data sources together.
And guess who needs to build these things? Developers. So developers aren't going anywhere.
That's right.
Don't believe everything you see out there. These AI systems still need us. So
that's right. Just build faster, build better.
The coolest things.
Cool.
And I think it's like maybe it's a trend. Is that they're making these MCP servers for their internal systems in order to generate reports. Give me information about something in my enterprise, and that's the new cool thing, and it is very exciting. One of the I don't think they're done yet, but one of the paths that they're going down is like, hey, they got all these regulations and requirements that they've got to understand. That's available from the government. So they build an MCP server for what's available from the government, the new things that are coming out, and then they make sure that their enterprise, hey, are we still in line? Like, it's wild. And we're just getting started.
Engines.
Compliance. Yeah, that'd be awesome.
Yeah. Automated compliance. Super fun.
All right. So, James, I'm going to put a link to the article that you wrote in the show notes for today's show. But outside of that, if anybody wants to connect with you, how can they find you?
I'm on all the places, LinkedIn, James Ward, and Twitter. I still call it Twitter, and Blue Sky. And yeah, those are probably the best. Yeah.
All right. Well, James, we really appreciate you taking some time today to talk about this, and we'll have to do it again real soon.
Sounds good. Thanks, Simon.
Maybe no more darts, though. Not against you two.
I can't wait to play darts with you all again. Going well.
Bring it on.
All right. Thank you, everyone, and we will see you next week. Have a good one.